Now I'm sharing the screen. Okay, let's get started. I am Alexander Varlamov, BI developer, and my speech today will be about unlocking the full potential of Tableau visualization. Some words about me. My journey with Tableau began back in 2016. I grew up in Tableau community. I started from Makeover Monday and other Tableau activities. Over there, I wore different hats as a Tableau as a Tableau developer, BI lead across various companies, and now I'm BI lead. I really like to experiment with Tableau, with math, and I like to craft Tableau visas and sharing insights through art. I was Tableau Zen Master and Tableau Visionary. 2 times I was Tableau Public Ambassador, and I was awarded as the hackiest is the Tableau Community Award. So usually in business we use three or four type of visualization. It's bar chart, line or area chart, scatter plot, and table. And it could be enough to cover 90 or 95% of business tasks. In my experience, and everybody knows what means show me. Show me, it's hint. So you can find visualization here, but it's maybe 5% of all Tableau power. And now I will share how to create complex visas and how to create not business visas, but the experience I'll share. It could be useful for some business cases. Okay, next. Evolutionally, humans are not adapted to numbers. Humans are surrounded by geometric objects, and their brains are well equipped to process the objects. We have a stereoscopic vision to access size, shapes, and distance to an object in space. It's my I started to think how to human to perceive this universe, and it's my opinion. When a person born, they don't know number, but their brains learn to recognize geometric objects of its own. Humanity invented the numbers to describe complex system. There is systems that help us better to understand this complex world. And the main idea here is data visualization is the transformation of numbers into geometric shapes to better understanding this world. The next, in BI system, there are ready-made visualization modules. As an example, I could say to show me. It looks like modules. A sheet in Tableau actually is a space or coordinate pane where you can visualize anything you want. Your task is simply to tell the tool of which sequence and where to place the points. When you realize that, in addition to basic visualization, to all kind of geometry, function, etc., etc., you can create all visualization you need if you use only school geometry formulas. That is great. This is greatly expands the range of the creativity. Here in my screen, it's a coordinate plane, and there is a point is drawn at the origin. Now, let's take 10,000 point to draw a circle. Mm, mm, Each dot here has its own coordinates. As you see, we have a circle. And next, try to create cloud of the points inside the circle using random values. Next step, let's try to create sphere and more 3D. And it looks like a pseudo 3D sphere. Now let's divide the sphere into three parts and add color. Then draw the line, draw the square, and fill the square with the color. So in this demo, I use only geometrical formulas to show that it's possible to make with points on this pane everything. So if you use function, if you use trigonometric functions, or maybe random, etc., it could expand your power in Tableau. Next, and the next one. If you would like to create something interesting or experiment with visualization, you could choose geometric primitives or geometric shapes, circle, square, etc. Choose type of geometric transformation, scaling, rotation, translation, symmetry, or other, and choose the level of granulation. Now let's visualize. Now I will share my visualization I previously made for Tableau Public, and this visualization it's about NHL. It's about hockey, of course. There are tracking system that monitor players' movement and actions. This system collected the data we see here, the intensity of the actions, and specific point is indicated by color. This result is a heat map where we can observe the frequency of various moments. Interestingly, on a single sheet, we can see where shot taken from all different hockey action occur. This helps us to better understand the game and can be useful for explaining to children who are starting hockey training. Concerning the visualization, how it works. So I go to the sheet of goals, and this is the plane or coordinate plane, and here each point has its own coordinate. So this is so-called coordinate plane from the school, maybe. Each point has its own x and y coordinates. This is a simple example of the geometric distribution of the points. So the next one is this visualization. Here we have the USA map. This visualization named how America uses its land. it's the visualization is designed in a storytelling format, so I could switch this parameter, and now we can see other type of visualization and text here. So how it works? Of course, square here has its own coordinate, but positions in specific parameters were calculated in Tableau directly. It's actually looks very interesting and very attractive. In other words, we used a certain function to create the desired distribution of the squares. Concerning this visualization, we have x coordinates, y coordinates, and the granularity we're using num. Num, it's ID of each square here. So and this is a good example of how we put some pixels points on a coordinate plane and control each position of this plane to make storytelling. The next visualization called eviction in San Francisco. You can find it on my Tableau public. Eviction in San Francisco was created as a part of the Make Our Money project. The map highlights the areas with the highest number of evictions using formulas to round latitude and longitude coordinates. The entire territory of San Francisco is divided into equal sections. We can see here. And within each section, the number of eviction is calculated. This is also a coordinate grid, but instead of points, we use lines. And there is an interesting effect here. It's added with a transition to a white background, giving the appearance of being drawn with a pen. The entire visualization looks as is if it we created with a pen and pencil. The animation also add to this so we can see animation here. And at the end, this visualization use on the coordinate plane with x and y coordinates. The same meaning as previous visualization, the same idea. My next visualization I can show you. It's how free is press around the world. Here we can see some geometrical objects, it's lines and curves, maybe curves, and I use sigmoids here. Idea of and main goal of this visualization to show freedom of press index and to connect with the country. Each country is represented by different press freedom indices across various years. Here we also use a coordinate plane, but combine two types of visualization, a ranking chart and a map. For the ranking, is here a visualization. We applied sigmoid function or S-shaped curves to create a smooth transition between ranking over different years. The ranking line connects directly to the country to represent freedom index. In this visualization, two coordinate planes from different visualization were merged. If we go to the Tableau sheet, we can see that it's one with 40,000. With with 100,000 marks. It's huge number maybe, but I made this visualization for make over Monday project, and this was created in January 2009. At the time, it was first kind of such a visualization. Now we can find on Tableau public similar experiment visualization. And I really like how we connect different types of visas, so ranking chart and maps, and the result, how it works. Concerning calculations. So let's look at this this calculation. It could be it looks complex, but the my idea here to normalize coordinates between the map longitude and latitude and between ranking. And I use only mathematical formulas to create this visualization. All sigmoid functions were calculated in the dataset, as I remember. And and idea the same. We use coordinate plane, Cartesian coordinates, to make interesting visualization. What next? Let's look to visualization number 5. Five is here. How do you think? How many points? Sorry. How many rows of the data and fields in the data set here? How do you think? If I select the dots, we can see a lot of dots, and I can change the portraits, and now it's complex. Sorry. And now we have Ben Kingsley. The interesting here, interesting thing here, that is the data set has only, where's my data? Here's my data. Only two numbers here, 0 and 500. So we have only two rows, only two numbers in the data set, but we can create such portraits, and also we can choose the complexity and change the drawing step. I mean, now I a drawing step. So in our mark panel, we can see 11,000 marks. And how do we get this? The secret that is that function. It is functions that were calculated in Wolfram Alpha, and I use densification method to multiply dots, and every dot here is point that's a result of parametric equation. So if we have mathematical function, we can represent it to parametrical equation as a function of t in my case. For example, Liam Neeson, x for Liam Neeson, the portrait Liam Neeson looks like here. So I zoom it. I will zoom it. It's extremely complex equation, but Tableau can calculate this equation and create this with and this one. I've been written about it, how I made this visualization with Python scripts and to adapt this method to Tableau. And it's a really interesting thing that we can create something without any data. So we use only two numbers. And Tableau allows to create this magic. It's not magic, it's math, actually. So the next type of visualization, it's what is this? It's Africa map. So here is a tile Africa map, and I use some geometrical shapes to fill the tiles. Also, I can change the gaps. I can reduce line thickness, and I can change the form of the shapes to create a different type of tile map. Each country is I already say that each country is represented by geometrical shape. The shapes is defined using formula within Tableau, all derived from basic circles. So I got circles, then change the shape of circles to create some polygons. Here the points are connected by lines. You can adjust line thickness, shapes, spacing, and level of detail. In other words, a variety of geometrical formulas are used to define the shapes. The shapes used here are inspired by traditional Japanese embroidery sashiko. So I found the formulas for the patterns. So let's look how to switch to a bow node, or maybe star, or maybe diamond. In this example of how you can chain shapes and the function that describe them, but simplify adjusting parameters. Data can also be overlaid on title map, and the size of titles can be adjusted, for example, based on country GDP. And I could use filter to make custom countries. So the interesting thing here, how it works, and now we can see coordinate x and y2. The dual axis here is for the text. I can remove this for the text and for the filling of the and where's my circle? Here's coordinates. If we look at the formulas, we use that we use here sinus, radians, cosines, and etc. So we use only trigonometric functions and how to say in English. I'm not sure that I know how to say. And this experiment show us that we use everything function we want to create something new. The next type of visualization names NBA hotspots. I really like sport visualization, and I really like NBA. This visualization, if I already have written an article about it, but this visualization highlights the hottest spots on a basketball court where famous NBA player have taken their shots. It's interesting to compare players like Shaquille O'Neal, here is Shaquille O'Neal, and Michael Jordan, for example. All the contours are calculated in Python based on jump shot data. These contours are imported into Tableau and displayed on a coordinate plane as polygons. Is the addition on a black polygons like here? Yes, it's not so easy. It's not so easy to click to these black polygons, but black polygons that's slightly offset from the original ones, creating a shadow effect. This type of visualization is extremely exotic, and it's known Tanaka contours. How it works inside Tableau? I have some parameters here to change the shape of these polygons. For example, I can choose and made it flat, like here, or maybe here, or maybe here. So let's look how it works inside Tableau. And now where's my there are all polygons here, and I use X, B, and YB for each polygons, and dimension X, and Y to divide this space into some subspaces. Inside each subspaces, I draw polygons. If we look at this, it's very simple. It's very simple. So I set this coordinate for Michael Jordan, for example, 1 and 1. So it's stable when I use where's my show header and this show header. So this is a table, and in seal 1 and 1, I put polygons of the Michael Jordan. It's a really interesting visualization, but very complex to create it because we need some Python and understand how to use a kernel density estimation. But I really like how it works in Tableau. Previously, I don't think that it's possible in Tableau, but as we see, everything is possible with mathematical equation and mathematical functions. And the next type. Sorry, how many time do I have to the end?
Until 7:50.
So
Until
20 minutes.
7.
Or
10 minutes?
No, like 20, but we need
20, really?
left couple for maybe for
Okay.
questions. So.
Okay, thanks. So my next visualization, for example, is 3D. It's a Lego house. And where's my steps? It's really looks impossible and in Tableau. And when I was start to create this type of visualization, I suppose that it's impossible. But if we understand how works projection formulas, you can create such type of visualization. And now we have a full 3D Lego house, and we can control the step of assembling this house, and how it works inside Tableau. The interesting thing that I use the same plane, the same coordinate plane, and so I draw each polygon on this plane. You can create a complex 3D object in Tableau using projection formulas. Projection formulas is something like here, maybe this. I have written a big article about it, about 3D, how to create such visualization. And the interesting thing that for this visualization, we have an hierarchy with a groups of polygons of bricks. So we can, for example, filter by group, or we can filter also by mesh. Mesh, where is the mesh? Mesh. It's it's called bricks, maybe in Lego. And Tableau allows to render it, to create it, and I never seen in other BI tools that it's possible create some types of visualizations. But when you create these visas, you really deep into the math and understand how to works projection formulas or trigonometrical formulas and etc. So in where is my Tableau public? Tableau public is here. In my Tableau profile, you can find other type of visualization, and maybe the most complex visualization called Japanese architectural heritage. It's also use coordinate plane to make visas. So on this vis, you can choose some architectural object, and Tableau is rendering it. We can rotate it. I create it as a vis where we can find the history and key points of each famous temples of Japan, and it's storytelling dashboard too. And also we can explore the buildings, the temples of the castle or the castles, or we can rotate it. And this is also use coordinate pane. So here is polygons, and let's look at other type of temple. For example, this Osaka castle. You can find description of this castle and key points of in history of this castle. Also, you can rotate this with this temple. So maybe it looks complex and impossible, but I started from the vis. Now I'd like to show my first vis, and really, and looks like this. It looked like this. When it's nothing interesting, just common bars, and I start to learn in Tableau community, and I really adore people in Tableau community, and really like how works the atmosphere and other activity of Tableau. You really can taught from Tableau community, learn from Tableau community, and also you can share your knowledge to Tableau community, and it's really it's a really awesome journey to be in Tableau community to create some visualization to experiment with forms, shapes, and other type of visualization. Now to the main presentation. What is the main idea of this? I show you 7 or 8 visas that has only one idea. By applying basic school level math and geometry, we can visualize data in any way we desire. Experiment is in visualization open up endless creative possibilities. Try, experiment, and enjoy. Thank you for listening. You can follow me on LinkedIn. You can find me on Tableau Public, and also you can visit my website, Cool Blue Data, where I was written some articles about Tableau. Thank you very much.
Thank you, Alexander. A lot of words here in chat that it's amazing job, etc., etc. So yeah, thank you. As a co-organizer, I will ask you a couple questions first, and then we will see what's in the chat. So first of all, yeah, your works inspiring me and my colleagues to start a Makeover Monday challenge in our company, etc., etc. But what's inspire you? What kind of resources? Maybe some, I don't know, publics or some public figures or some where you find your ideas and find your creativity.
To my experience, when I started to learn from people in Tableau and Tableau community, data family, I used reverse engineering. So I download some workbooks and explore how it works. It's really good techniques to understand how it works. And after that, I started to remake something that community already made. Then I started to learn in Makeover Monday. It's a really huge community from huge idea, and you can share, speak with people, and you can find all maybe big quantity of awesome visualization and that inspire you. This is my huge so-called universe of inspiration. And when after that, I started to experiment. So I started to make something that nobody nobody creates in Tableau before, and it's really a challenging thing. But for example, each next visualization, I don't I was not sure that it's possible in Tableau, but now I'm sure it's possible. And the answer is the simple. It's just geometrical formulas, nothing more actually. And also, I read articles about visualization, and I follow some people in Twitter, LinkedIn, and see what they create.
Okay, thank you. And one more, as I asked you, Luis, what's the hardest part of this one? Because yeah, we of course see these big formulas, etc., but I think it's not the hardest part. Well, so what is if you creating
I
this
understood.
as a work?
Uh, the hardest part it's at the start to create something that you sure that it's impossible. It's the hardest part because I was afraid. Really, I was afraid to create something new because it's looked complex. And if you have to make a step to explore something new, it's okay. But the hardest thing it's really to make the first step to create something impossible for you. For example, try to create be um, be better than you yesterday's. And my advice: don't see at expert and etc. Try to use better each day, better than previous day. It's and you will see the progress.
Great. We see in the chat some questions. So, how much time did you spend on Japanese temples with approximately?
Oh, in Japanese temple. So it was winter, and it was it was January. So I have a lot of free time because there was holidays in, and I started to recreate some methods mm, that people already used for Tableau, and I spent a lot of hours for understanding 3D formats. So it's I described it in my articles on my website, but it's really I really love it, and maybe 15 days, maybe more. I don't know. Maybe a month, something like this.
Okay. Yeah. So, and also next question, can you imagine choosing similar custom visualization to solve business tasks rather than using default visas? Or it's more about data for graphics?
So for infographics, yes, it's possible, but the most of people use business visualization. I apply some mathematical formulas in my business visualization because I use table calculations when we and some formulas from my public visualization I really use in my business visualization. But I should say that our business visualization looks not so simple like basic visualization because we work with designers, and it's really complex dashboards. That's all. Thank you.